It is a dream of mankind to fly like a bird. Birds are very agile. They fly not with rotating components, so they fly only by flapping their wings. So we looked at the birds and we try to make a model that is powerful, ultra-light, and it must have excellent aerodynamic qualities that would fly by its own and only by flapping its wings. So what would be better to use the herring gull in its freedom, circling and swooping over the sea, and use this as a role model. So we bring a team together. There are generalists and also specialists in the field of aerodynamics, in the field of building gliders, and the task was to build an ultralight indoor flying model that is able to fly over your heads, so be careful later on. And this was one issue, to build it that lightweight that no one would be hurt if it fell down. So why do we all this? We are a company in the field of automation, and we'd like to do very lightweight structures because that's energy efficient, and we'd like to learn more about pneumatics and airflow phenomena. So I now would like to take your seatbelts on and you put your hats off. So maybe we try it once to fly SmartBird. Thank you. So we can now look at the SmartBird. So here is one without a skin. We have a wingspan of about 2 meters. The length is 1 meter and 6, and the weight, it is only 450 grams. And it is all out of carbon fiber. In the middle we have a motor, and we also have a gear in it, and we use the gear to transfer the circulation of the motor. So within the motor we have 3 Hall sensors that we know exactly where the wing is. And if we now beat up and down, we have the possibility to fly like a bird. So if you go down, you have the large area of propulsion, and if you go up, the wings are not that large, and it is easier to get up. So the next thing we did, or the challenges we did, was to coordinate this movement. We have to turn it, go up and go down. We have a split wing. With the split wing, we get the lift at the upper wing, and we get the propulsion at the lower wing. Also, we see how we measure the aerodynamic efficiency. We had knowledge about the electromechanical efficiency, and then we can calculate the aerodynamic efficiency. So therefore, it rises up from passive torsion to active torsion from 30% up to 80%. Next thing we have to do, we have to control and regulate the whole structure. Only if you control and regulate it, you will get that aerodynamic deficiency. So the overall consumption of energy is about 25 watts at takeoff and 16 to 80 watts in flight. Thank you.
Markus, I think that we should fly it once more.
Yeah, sure. Okay.
If you did an internet search in the greater Detroit area, you'd see bad news. Companies closing, that houses were being foreclosed upon. However, when there are negative things going on, there's also opportunity. And for people that look for it, like Dave, they see the opportunity and they say, I can make a difference here.
There's a constant stream of negative news about, economics and whatever. And so it's nice to inject some positive news coming out of Ypsilanti. It's motivation to make you want to do something to help out your town. So my friend Corinne, who is the manager at the Ypsilanti Food Co-op, sent me what she thought was a grant for a solar project. Turned out it was a very low-interest loan. So it kind of sparked my interest, and then I did some searching and was able to actually find a small $6,000 grant from the state of Michigan. But I've never done solar. I didn't know square one about how it was done. We bought panels, we figured out how to do it, and that was our first system. We needed to monitor the power and be able to track how much is coming in and out. I did find products that would do this for us, but those products could cost thousands of dollars. We didn't have $1,000. We invented a way to read utility meters for essentially free. My goal is to see a cloud. And I wanted to see a nice, smooth solar graph, and then I wanted to dip a little bit and know that a cloud just went over the solar panels. My wildest dreams is to have 100 locations in Ypsilanti, all on Solar Ypsi, all being tracked in real time. And Ypsilanti would be the place to come for solar information. When I started, I was searching and I was looking in 10 or 12 different places. And so now we have a website where information's already been collated, and so someone can search on solar, find this site, and hopefully have all the information they need. It's just amazing that you see people in far-off remote villages in like Mongolia, if they're looking for solar power or for some information, it's there for them to find. And it's happened, it's so cool.